in this case, for example, let's see here. Okay, let's go back to the camera. So as you see here, if this object here, if I put my fingers like this, right, that's how you measure. See this angle here, right? This angle here that is open between the thumb and the index to measure the angular diameter of this object. The thing is that if I put the object further out, then I have to close my fingers. You see here when I put the line here and the line here, and you see here the angle became smaller as the object became further out. So the angular diameter is affected by the distance between yourself and the object. And the same thing with the sun, right? I mean, you can put your fingers very, very small angle, and you can put, you can almost reach the edge of the sun on top of the bottom. And the sun is millions of kilometers in diameter. So you say, how can that be possible? Because the distance is also great, right? So since we know, right? I mean, in this case, you are told. So let me get back to the screen. So you see here that you are given an expression that shows what that angular diameter depends on two things: the size of the object and the distance between you and the object, you as the observer and the object that you're trying to experiment on. And here, the numerator is the size, the actual size of the object. So don't think that D means distance. That's whoever wrote this problem obviously made that choice. I wouldn't have made it that way, because size and distance, size should not be carrying the letter D, which usually stands for distance, right? But then again, somebody says, hey, R also stands for radius, for distance, for whatever, right? So just remember that the numerator is about the size of the object, and R is the distance between you and the object. Of course, here he uses small r, becomes capital R, because most likely when they copied and pasted this expression, it was capital R, but in the text they wrote small r. So yeah, there are some discrepancies here and there, but otherwise that means I can tell you. That means if you tell me the size of the object and you tell me the distance, I can tell you what the angular diameter is. If you tell me what the distance is, what the angular diameter is, I can tell you the size of the object. So that means given two, I can give you the third one. That's what I'm trying. And you may have to go either way. That means given D and R, you get theta. Given D and theta, you get R, and so on, right? You have to be able to go in both directions. And so the whole project part here is about related to somehow the sun. Right? And you see here that there's a spacecraft that is flying, or that has been directed to fly towards the sun, right? And even though the distance is great, but it can get as close as 5.8 million kilometers from the sun. Because at some point, if you get too close, you're going to burn, right? I mean, the rocket would burn. And so what we would like to see here is that as an example, right? First as an example, which has nothing to do with the project, right? Just to practice. What we want to know is if you look at your thumb, right, and you want to know what the angular diameter is for your thumb, right? Of course, in this case, you use the left hand to have the index and the thumb on the edge of the thumb as it is far away from you, and you look at the angle, and that's what you're supposed to find, right? And I can tell you that it's not exactly 1.8 degrees. So whoever did these calculations did it with simple approximations like tangent 0.016. That's not a number that is acceptable. You have to work with these numbers, right? And plug them in. So do that with MATLAB and tell me what theta is equal to based on this expression. Go ahead, do it now. And tell me what the exact number in degrees. I want her in degrees, of course, not in radians. Every time you move something far away from you, it looks smaller, right? 1.91. Can anybody confirm that? Come on, guys, I'm waiting for confirmation here. And there'll be two options. Either you don't have MATLAB, or you have MATLAB and you don't care about practicing because you just want to see what everybody else is doing. You're just there as an observer. And I hope that's not the second case, right? If you don't have MATLAB because you're in the car or on your phone, I can understand that. Otherwise, that's a problem. So anybody confirming? So annoying. So annoying. Can somebody come up with a good excuse why they're not participating? I mean, you want to pass the class, at least put some effort into it, right? I'm not asking you to do something difficult. Put some effort into it. Otherwise, you're asking me for compassion when you're not doing your job. I'm not asking you to be good. I'm just asking you to be a doer. Do something. And if you cannot do it, just give me an explanation right here, now. What did I say before? That before you even, yes, Shafiq, that's very good. I like that, right? But even for Christians, you should always load MATLAB before you even come to class, right? It should always be, because when you have to practice, you're not going to practice by watching me do it or watching Shafiq or watching Dov or whatever, right, David? And it's all right. It's all right. It's all right. It's all right. I mean, if you give me that explanation, I'm happy. I'm happy to see the numbers from Nicholas, even though Nicholas must have used the calculator, right? Because otherwise, why would you have a fifth digit? That's strange, unless you used some kind of a program that lists 5 digits or something. Who knows? But theoretically, if you use it directly, that's why. Yes, where is it? Where are you? I know. You use the calculator, right? So I'm just showing you. This is the arctangent D because I want degrees. 2 times, right? This is the size of the object, which is 2 centimeters. Supposedly, if the thumb is 2 centimeters, it's really half a thumb, right? And then divided by 2 times r. And I had to put them in parentheses because I want to divide by the whole thing, right? By 2 times 60. I could have put 120, but I just let MATLAB do the job for me, right? Theoretically, even the 2 and 60, I could have had them in a script file, d equal this, r equal this, right? And then write my expression just with literals, right? Just the variables names, right? And let MATLAB plug in the thing in there, right? It's not for me to do any intermediary calculations, right? Because tomorrow I may need the same expression with different sizes and different distances. So why would I rewrite the entire expression? I just need to change the numbers. So theoretically, I go script here, right? Where are you? For example, and I say, for example, d equal to, no, I stay on the same line. I'm going to use capital R, doesn't matter. Or maybe small r, the head with a capital R, is 60, right? And then I say theta equal, right? Theta equal 2 times arctangent a10 d of d, that's the size, divided by, and in between parentheses 2 times r, and that's it, right? And then I run it, right? I run it. Of course, it's going to ask me to save it, which I hate to do. So I'm going to leave it untitled. That way I can erase it anytime I want to. And so as you see here, it's the same answer that I get. Theta equal, right? And so if I wanna change this to maybe not 60 centimeters, say 1,000 centimeters. That's about that's 10 meters, right? Because a centimeter is a hundredth of a meter. Centimeter, centième du mètre, right? And so in this case, that's 10 meters away. And so when I look at how it goes down to 0.1 degree, right? 0.1 degree. And of course, if I put 2 centimeters away, right? And then I look at it. That's 53 degrees. You remember that when I put my fingers between that's about 53 degrees, right? And maybe that's 2 centimeters away, right? 2 centimeters away. And of course, if I put 0 centimeter away, that means next to it, right? Then I get 180 degrees. Theoretically, of course, that means my fingers would have to open up all, right, to get the thing to get. So that's, you see here, the beauty of the script file, right? I changed one number, I didn't have to retype anything. You just run it as many times as you want. This is the beauty of script file. This is the beauty of a programmable system. This is the beauty, of course, on a calculator. If it has the capability of a computer, that's fine. But otherwise, you will have to type in more things to evaluate. Like in the old days, even though it's called a programmable or calculator, but you still had to program the entire expression somewhere in memory, and then store some numbers in memory, and then run those expressions, right? Evaluate the expressions. And before that, that was impossible. You had to go through every step, one step at a time, right? You change the number, you have to go through all the steps, every part of the expression, every one of them, every calculation, every step in the calculation. And of course, before that, there was pieces, on paper. The problem with MATLAB is that it is so complex that unless you have a calculator that has the capabilities of a computer, that means a CPU that is powerful, right? If you take, let's say, a tablet, it's not going to do it, right? It doesn't have powerful CPUs and powerful architecture, powerful memories, and so on, right? It's but most importantly the CPUs, right? So, like if you take a Surface type of laptop, then yes, because that is designed to be a computer as a laptop tablet. But ultimately, it's still a computer, right? The way we know it. Laptop, desktop doesn't matter, but they have the power to handle major amount of calculations over an acceptable period of time. So it's all about also time again. Remember, time is important. So don't tell me you didn't have enough time for the exam. If MATLAB gives you a solution every 10 hours, you would be very upset. But of course, if I tell you the truth, about 35 years ago, sometimes I had to wait 3 days for a result to pop up. Can you imagine 3 days? But I was happy because those 3 days, if I had done to do the calculation by hand, it'd be like 6 months. 6 months by hand. And here it happened in 3 days. I was so ecstatic. Same thing with industry. The engineers would wait 7 days before they can extract an optimum solution because the program, the algorithm has to work many, many times before it finds the optimum solution. And then from there, they tweak it a little bit, right? They use MATLAB to tweak things. So they do things by hand, then they tweak things through MATLAB, and then they have the optimum solution, and they're happy. After 7 days, which is better than, a whole year, and many engineers involved. Here's just a machine. Boom, here it is. 7 days to 7 microseconds, and we are still not grateful for that, right? Well, that's why when you do calculations, you have to make sure you can confirm it at least in one case. Say, for example, if I had to do it by the calculator or by hand, or the number already makes sense. Or if I do it through a calculator and I get the same number, then I am confident in the expression that I wrote or the program that I wrote, and now I can use it. Of course, in life, there is no way you can guarantee that a program will in all conditions. That's why we have benchmark programs, right? That means you run it through some program, you run some programs through the machine or some situations, right, for your program. And if for those situations it gives the appropriate results, then you can say, okay, I think it's going to work all the time. That means in all situations. Of course, this is not guarantee it, but at least it gives you more confidence. So you always have to try something that you know the result for. And if it gives you that number, then okay, you build up some confidence in the fact that it would also work in other situations or give you the correct result at least. Yeah, what about if it was wrong? The result? Well, no, because when people get to the computer, by that time, they already did things by hand, so they know, based on the theory, it should make sense. So the computer is there only to give them numbers. It's not to verify the theory or not, it's just to give them numbers. But that's true. I mean, if the theory is weak, maybe the way they obtain they have to go again. At least they would find out, right? Here's the theory is not very good, so we have to change it. Or at least they didn't have to wait 6 months. They only waited 7 days. So obviously, that's a lot of money to pay people for 6 months, and then 6 months, and then, right? So time is money, right? That's why I said, your intelligence, the employer will still pay you. But calculations, oh, no. I need a month. Sorry, I can do it in a microsecond. Sorry. Right? So you have to be careful there. Right? That means you have to be good at all those many things, right? All right, going back to the project. So in this case, it was just a practice, right? But what they're telling you to do, and of course, it's all through MATLAB, not through a calculator, as far as the project is concerned. They're asking you to figure out what that angular diameter is, that means theta, when the distance is 147 million kilometers, that means R is 147 million kilometers, and the size of the object is 1.4 million kilometers. That's a huge sun, right? Right? And 147 million kilometers, that's a major distance. That's why to you it looks like nothing, right? It looks like a little circle, right? But really it's 147 million kilometers, the distance that makes it look so small. So this is, again, if I had gone to my script file, I put 1.4 million kilometers as a size, 147 million kilometers as a distance. And of course here, I could have said 1.4, this is 10 to the power 6, this is 10 to the power 3, I could have said 10 to the power 9 meters. Same thing here. Or I could just put 1.4 and 147. Why? Because million kilometers will appear here in the numerator and the denominator. So they don't have, then I don't have to write the numbers because they have exactly the same suffix and the same units. So as long as I keep track of those, I could put just 1.4 on top and 147 at the bottom. Or I can put 10 to the power 9 if I want to work with the international standard, right? Meter, seconds, and stuff, kilogram, whatever. Then they're asking you that if you were in that, how big would the sun look like if you were inside the probe? And the probe now is not at 147 million kilometers, it's only 5.8 million kilometers. So the sun is going to look like a giant circle because you're closer, and the closer you are, the bigger that angular diameter, right? All the way to 180 degrees when you're like, that's it, next to it, right? So that shows you that an object would look bigger as you get close, smaller as you get farther away. And so that means, again, it's just problem one. The only thing that changes is the distance, which is 5.8 instead of 147. Big deal. However, third one is like a reverse operation. They say, imagine you had that angular diameter. Which one? Oh, the one from problem means whichever angular diameter you got in problem two, right? Whatever that value is, right? So imagine you're holding a DVD disc in your hand, far away from you, right? Far away from you. The disc measures 12 centimeters in diameter. And they say, how far should it be? That means find R so that the angular diameter is the same that you obtained in problem two. So now you know the angular diameter, you know the size of the object, you need to find the distance. That's it. Very simple. That's this fourth part of the project. It doesn't take more than 15 minutes. Of course, it takes a little more because it's not a matter of calculating things. I want to see things with using sentences and units, right? So I don't want to give take points off unnecessarily. But if it's not presented in sentences with units, you're gonna be sorry that you provide so much effort for very little points, very few points. So just remember that all these parts of the projects, everything should be provided through sentences, including units, of course. No, there is no, I told you at the beginning, there is no individual project. Every one of them, regardless of what it says, every one of them is a group submission. In fact, you take all the 7 parts and you put them together and you submit just one file. Yes. So it doesn't matter if it says, individual. I doubt that it says that here, but yeah, teams, right? But even, I think the next one, it doesn't say teams. It says teams also. So even if one of them says individual, ignore that. It's all teams, right? It's all teams, because I want people to learn to work together. When you work together, you achieve more. When you don't, as long as not one of you is a leech, right? They take but they give nothing. They don't help. Now, number 5 is much simpler, in a sense that it says here, you're on programming MATLAB. That means you decide what the problem is, you decide how to solve it, you decide how to present it, and so on, right? That's your decision, right? However, there are a few conditions, is that the program should be more than 10 lines. And of course, if you write how to turn the file PDF again. What do you mean how to turn the file PDF again, Shafiq? Or how to publish it in PDF? You remember the publication, publish, and options? One of the options is PDF. Otherwise, put it in doc. Just leave it in document format. Okay, well, let me see here. Let's see where are you program? My program. For example, this one, right? And you see here when we say publish, right? When you say published, first you have the options, right? Which is the little black triangle, and then you say edit, publish, and options. That you do only once when you start MATLAB, right? And here you see HTML, and when you press on it, then you have doc and you have PDF, right? So you could choose doc or you could choose PDF, and it comes up as PDF automatically, right? As you publish. For example, if I go PDF and I say publish, you have to wait. Okay, this is your PDF, right? This is your published version of it on the PDF format. Of course, you have to have Adobe Reader or something, something to read PDF files, right? But could have also published it as a document file. Yes, as a document file. So in this case, instead of PDF, I could say doc. The problem with the document, some of you don't have Microsoft Office or something. Now, the only problem with problem 5, I gave 10 to some people who wrote fantastic programs. Why? Because I am sure they did not write their programs. Because it contains functions beyond, sometimes even beyond me, to know they existed. I say, how the hell you cannot answer the simplest questions? You can things like that. That means they picked up the program from somewhere, and that's it, right? This is not acceptable for me, right? That you write a sophisticated program that you take from somebody else. It's the idea of showing that you can use MATLAB in your schoolwork. So I prefer that you take a homework problem or some example that you did in class and use MATLAB to show the results. And of course, when I said 10 lines, I hope the 10 lines are not like A equal 2, B equal 3, C equal 4, D equal 5. No, they could appear like a single line, right? Equal 3, that is a single line. So they don't count as single lines. Lines should have been, different instructions, right? Oh, please be careful. So if you write a game, but it's your game, the way you wrote it, and I know it like it's basic enough that I can believe you, that it is yours, I will accept it, right? But if it looks too sophisticated, I will hurt you. And so that's why I said I prefer that you take any example from other classes and show that you can solve it through MATLAB or present the results through MATLAB. That would be even better. I feel bad for Christian. Yeah, I mean, it shows you're a gamer, right? You love gaming. Except, you know, I think gaming is useful when you program for others. Who was it that, I don't know, who the entrepreneur, that was very famous. But at 10 years old, he wrote a program and he sold the game for 250 bucks. Is that Elon Musk? Maybe it is. I think it's Elon Musk, maybe. 250 bucks at 10 years old. He wrote a game that somebody liked as a program and they bought it for 250 bucks. Or maybe some company, who knows, I don't know. And that starts with something basic and then suddenly, boom. Now you can create an electric car, you can create a rocket, you can create who knows what. Sophisticated machines, digital machines, you name it, right? Aside from discovering the wheel, look at the GPS, wow, how useful it is. A simple program, but somebody may think it's simple today. But not long ago, you had to have thousands of researchers trying to figure out how to present it. Amazing, isn't it? Okay, so that is about it as far as this this project is concerned, because 7, I will not talk about until I talk about Excel files, on how to access Excel files and get the data from them to be used in MATLAB. Because in real life, most people have their data that are stored in an Excel sheet, right? Or kind of like spreadsheet. So they want to make sure that if you paid somebody to enter all those numbers, you don't have to pay again to enter them through MATLAB. We'll just pick them up for you because they are in a format that we can read. The other one that I haven't discussed yet and will not discuss now is how to create a musical piece. A piece of music, right? I think I played already a piece of music for you before, so you know, right? It's just a matter of notes. And if you put notes together, that becomes music. So we're going to discuss that when I present first how to create these notes through MATLAB, and then how to put the notes together to create a piece of music. That's your problem, right? You show me your artistic side. And again, the same thing that what I have said about part 5. Anybody who gives me a piece of music that I don't believe they wrote, then I will be very upset, right? That means they copied it from somewhere. But because sometimes I believe the students when I know, I can see, I can prove their artistic side. Maybe they're used to writing songs or something, so I can see that, right? Possibility. But if somebody does not know his notes or her notes and is able to write a fantastic piece of music, and I say, okay, I don't believe you, even if it's true. But that's not true. I mean, that means the likelihood that it is true is like, 0.1% maybe or something. I don't know. So at some point I may be, doing some harm to a student, but most of the time I'm right? And so plagiarism is something you get fired for. So you have to be careful. Right now you can get away with things, but when you work and the company gets hurt because you copied somebody else's work, then you get fired, if not worse, right? If not worse. So, what do you have to say, Christian the gamer? Christian, what do you have, man?
Yes.
There's something. Go ahead.
I'm ready. Just talk. Okay.
Go ahead, Christian. Tell me.
Well, I don't really have anything else to say, but as a mechanical engineer.
As a gamer, what do you have to say about games?
My game.
What the interest you develop for games? What? How? Why?
Because I just wanted to create a game and just share it.
Oh, it's not just playing a game. You want to create a game.
Yes.
So go for it, boy. Go for it, man. I would be so. If I know it's your work, I would advertise it to the whole department if I had to, because that's a major way of showing how creative one person is. Yes, it may be just a game, but remember, what is it? War games. Some game that becomes like a basis for an entire serious situation. So you never know, right? I mean, sometimes the games are used to train the machine to learn by itself. Of course, that's for sure. Yes, unfortunately. Yes. And then somebody else will create, because if you look at the games today, they're not the games like Atari and whatever, little chips with very few components inside, they do specific things. No, here we're talking about the major sophisticated machine. In fact, the CPUs that are used for gaming consoles are more powerful than the CPUs you use in your laptop. And that's why they thought that in the future, the newer laptops will have to use the gaming CPUs. Because the volume is so huge. When they sell them, they decided, yeah, now we're talking VR, right? Yes, except VR gives me a headache. So I remember once I watched a movie where, including dinosaurs, and I thought the dinosaurs were attacking me, even though I knew it was a game, it was nothing. When I looked down, it's like empty space. I said, what the hell? I know I was sitting on the chair. It's amazing how the brain, functions, right? They can play with your brain without, even though you are aware, but you're still reacting, instinct. But I love it, though. I love it because maybe someday I can play sports without, moving from my chair. Yes. As Facebook is also trying to avoid paying taxes, by the way. They're doing it like Google, right? They have a parent company, supposedly, whose headquarters are in Ireland, where they pay close to zero taxes. And so the entire Google, which makes probably trillions of dollars, will pay $5 in taxes. And now Facebook wants to do the same thing. Interesting, isn't it? I mean, loopholes are like a major problem. And you think that the politicians right away, when they find out about it, right away they will find the solution. They're all corrupt. Not all, but many of them. They have to follow the money trail, right? I mean, who are you that I have to take care of you? You're not paying, my funding, my election thing process, right? So they're human beings like you. If you look at whistleblowers, they're trying to do the right thing by the people, and people will get upset with them because when they open their mouths, the company will go bankrupt and everybody lose their job, and now they're upset. You say, wait a minute, but what I said was good for society. Oh, I don't care about society. I care about my job. I lost it. So when you do the right thing, don't expect to be thanked. Don't expect recognition. You do it because you believe in it, or just don't do it. Period. All right. So I think maybe we should take a break, and then we go back to lecturing from chapter 4. So we'll talk some more. Do you have any questions? No, Alexandro has no questions, and he probably speaks for the section. So we'll just say then see you in few. Don't go away. I mean, you can go away, but you have to come back.